Good morning. I'm Devisena. In this lecture, we are going to discuss about block diagram reduction solved problems part 2. This topic is present in the subject control systems. Block diagram reduction solved problems part 2. Problem 1. Reduce the block diagram shown in figure below and obtain C of S by R of S. This question is asked in Anna University, May 2007. This is the given block diagram. For this block diagram, using block diagram reduction techniques, we have to obtain C of S by R of S. Step 1. Here is the given block diagram and this is the takeoff point T1. This takeoff point is present in between the blocks G2 and G3. Because of this, it is not possible for us to eliminate the feedback loop, inner feedback loop. So we have to shift the takeoff point between the blocks G2 and G3. This is our step 1. Step 1 is shifting the takeoff point T1 between the blocks G2 and G3 towards after the block G3. That is towards the output side. This is indicated in this diagram. Here is the block diagram. After shifting the takeoff point between the block G2 and G3, we get the block diagram like this. So initially the takeoff point is located between the blocks G2 and G3. Now it is being shifted after the block G3. So if the takeoff point is shifted after a block G3 means we have to include a block 1 by G3 along with the block G5 because the takeoff point T1 is connected to the block G5. It is indicated in this diagram. Step 2. Here is a block diagram. Now we have to identify the blocks which are in cascade. In this diagram we are having the blocks G2 and G3 are connected in cascade as well as the blocks 1 by G3 and G5 are connected in cascade. Now we have to combine the blocks G2 and G3 as well as 1 by G3 and G5 which are in cascade. It is indicated in this diagram. After combining the blocks G2, G3 which are in cascade as well as G5 by G3 which are in cascade, we are having the block diagram like this. Now we have to identify the inner feedback loop 1. This is the feedback loop 1. The feedback loop 1 is indicated in this diagram by an arrow and we are having the blocks G4 and G5 by G3 which are in parallel. This has to be simplified. Step 3. We have to eliminate the feedback loop 1 and combine the blocks G4 and G5 by G3. By doing this elimination of feedback loop 1, the summing point S2 is being removed. Here a negative feedback is applied to this, therefore the form using the rule eliminating the negative feedback, the value will be G2 G3 divided by 1 plus G2 G3 H1. This is your resultant block after eliminating the negative feedback loop. Now the blocks G4 and G5 by G3 which are in parallel. If we are eliminating the blocks in parallel, we have to use the rule combine the blocks if the blocks are in parallel. That is, we have to add the blocks G4 and G5 by G3. By combining the blocks which are in parallel, the summing point S3 gets removed. So the resultant block after combining the blocks which are in parallel means we get G4 plus G5 by G3. This is indicated in this diagram. Now we have to identify the blocks which are in cascade. In this diagram we are having the blocks G1, block G2 G3 divided by 1 plus G2 G3 H1, and the block G4 plus G5 by G3 which are in cascade. Now we are going to combine these three blocks which are in cascade in the next step. Step 4. Combine the blocks which are in cascade. After combining the three blocks in cascade, the resultant block will be G1, G2, G3 into G3, G4 plus G5, the whole divided by G3 into 1 plus G2, G3, H1. This is the resultant block. This is indicated here. Now we have to identify the feedback loop 2. In this diagram, here this is the feedback loop 2. Now we are going to eliminate this feedback loop 2. The feedback loop 2 is having a feedback signal H2. This H2 is applied to the summing point S1, which is having a negative sign. So we are going to eliminate this feedback loop 2. Eliminate feedback loop 2. This is the value C of s by R of s is equal to, in the numerator we have to put the G of s term, and in the denominator we have to put 1 plus G of s H of s. That is, this is the formula for eliminating the negative feedback. In this block we have the value of G of s as G1, G2, G3 into G3, G4 plus G5 divided by 1 plus G2, G3, H1 into G3. This is our G of s value, and we have to substitute the value of G of s to both in the numerator as well as in the denominator. So we get the value of C of s by R of s like this. After simplifying this, we get the value of C of s by R of s as G1, G2, G3 into G3, G4 plus G5, the whole divided by G3 into 1 plus G2, G3, H1 plus open bracket G1, G2, G3 into G3, G4 plus G5 close bracket, the whole into H2. This is our final answer. Part 2, problem 2. Using block diagram reduction technique, find the transfer function from each input to the output C of s for the system shown in figure below. This question is asked in an university 2005. Listen, in this problem, two inputs are applied. One is X of s input and the another is R of s input. We have to consider one input at a time and we have to solve this problem. Okay, so in this, initially we have to consider the R of s input and we have to substitute X of s is equal to 0 and start solving the problem C of s by R of s. After obtaining the value of C of s by R of s, we have to consider X of s input by keeping R of s input as 0 and proceed the problem. With X of s is equal to 0, the given block diagram reduces us. This is the given block diagram. If we consider the value of X of s is equal to 0, that is, we are considering the input R of s alone. Now, identifying the summing points feedback loops in the given block diagram. In this block diagram, we have three summing points S1, S2 and S3, and we are having three feedback loops, feedback loop 1, feedback loop 2 and feedback loop 3. This is indicated in this diagram. Feedback loop 1 is a unity feedback loop. We have to identify this. Here a negative feedback is applied in this diagram, and feedback loop 2 is having a feedback element of H5, and this H5 is applied to summing point 3, which is having a negative sign. That is, a negative feedback is applied to both the feedback loops. Step 1 continues. Eliminate feedback loops 1 and 2. The summing points S2 and S3 are eliminated. After eliminating unity feedback loop 1, the block is indicated as shown above. It is having a value of G2 divided by 1 plus G2. And similarly, if we eliminate the feedback loop 2 means the block is indicated as shown above. The feedback loop 2 is having a feedback element H5. A negative feedback is applied. Therefore, the resultant block will be G5 divided by 1 plus G5 H5. Step 2. Identifying the blocks in cascade. Here, the blocks G2 divided by 1 plus G2 and G3 block, as well as G5 divided by 1 plus G5 H5. These three blocks are in cascade. So combining the blocks in cascade we have to do. To continue. After combining the blocks which are in cascade, we get the resultant block as G2, G3, G5 divided by 1 plus G2 into 1 plus G5. Now we have to eliminate feedback loop 3. The feedback loop 3 is having a unity feedback. The unity feedback is applied to summing point is 1. Unity negative feedback is applied to summing point S1. After eliminating feedback loop 3, we get the block like this. Here, now we have to combine the blocks G1 and the G2, G3, G5 divided by open bracket 1 plus G2 into 1 plus G5 H5 close bracket plus G2, G3, G5. These blocks are in cascade. We have to combine these two blocks which are in cascade. After combining the blocks in cascade, we get the resultant block like this. That is, C of S by R of S is equal to G1, G2, G3, G5 divided by open bracket 1 plus G2 into 1 plus G5 close bracket plus open bracket G2, G3, G5. This is the value of C of S by R of S. Now, by considering the input R of S alone, now we have to consider the other input X of S further. Part 2, problem 2, case 5. This is the given block diagram. Now consider another input X of S. By considering the input R of S is equal to 0. If you consider input R of S is equal to 0 means the block G1 vanishes. But minus sign at the summing point S1 must be considered by introducing block of minus 1 as shown in this figure. Identifying feedback loops 1 and 2. Here is a feedback loop 1. Feedback loop 1 is connected to the summing point S1 and feedback loop 2 is connected to the summing point S2. This is indicated in this diagram. Eliminating feedback loop 1 and 2. If we eliminate the feedback loop 1 means we get the value G2 divided by 1 plus G2, because for the feedback loop 1 unity feedback is applied, which is having a negative sign. So after eliminating this feedback loop 1, the resultant block will be G2 divided by 1 plus G2. Similarly, we have to eliminate the feedback loop 2. Feedback loop 2, that is, it is connected to the summing point S2. Already for the summing point S2, one signal is coming from G4 block, which is having a positive sign. Then other signal is coming from G3 block, which is having a positive sign, and a third signal is coming from the output. That is a feedback loop which is having a feedback element H5. So if we eliminate the feedback loop 2 means the resultant block will be G5 divided by 1 plus G5 H5. After eliminating these feedback loops 1 and 2, now we have to identify the blocks in cascade. In this diagram, the block G2 divided by 1 plus G2 minus 1 and G3, these three blocks are in cascade. So we have to combine the blocks in cascade further. Blocks in cascade after eliminating the feedback loops. If you look the block diagram means, here we have three blocks, that is minus 1 block, G2 divided by 1 plus G2 block and G3 block. These three blocks are in cascade. So we have to combine the blocks in cascade by applying the rule combining the blocks in cascade, that is multiplying the individual blocks for removing these blocks in cascade. Step 7. Redraw the given block diagram and combine the blocks in cascade. Here is a redrawn diagram. Step 7. Identifying the feedback loop 3. In this diagram, the summing point S2 is connected to a positive feedback which is having a feedback element of minus G2 G3 divided by 1 plus G2. So this has to be eliminated. Step 8. Eliminate the feedback loop 3 and combine the blocks in cascade. We get the resultant block like this. That is C of s by x of s is equal to G4 G5 into 1 plus G2 the whole divided by 1 plus G5 H5 into 1 plus G2 plus G2 G3 H5. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means you can share this video to your friends.